So yeah, the single layer perception is the basic neural network. So yeah, some of the students may ask me, yes, why we need so many layers and then we need so many nodes for the hidden layer, etc., etc. So honestly, in the real world problem, we are not dealing with only simple the milk bottle and handkerchief to detect whether we are not quiet or not. So somehow we have a more and more complicated question. For example, so one of the questions that we have mentioned before is the probability of your happiness. Okay, so your happiness is based on the GPA and then it's based on your fans, etc. And then perhaps I'm also a depression. Okay, I have depressions. So I have the bias of the happiness, and then happiness, the starting point will be -15. So yeah, it's normal, right? So honestly, we guys are university, yeah, we are higher education, and then you are university student. And then if your GPA is really, really low, and then if you do not have bands, and then you still feel you are happy, then you are you're too happy, right? So more of us, so we have some expectation, and that is the bias. So the bias is negative, and -15. I don't know whether this one is true or not for all the students. Similar to the previous example about the milk bottle and then also about the handkerchief, right? So we just randomly assign the weighting into it, -15, 6, 10, and then we have the summations of all the linear equations, and then we have this equations for estimate our happiness. Okay, so if it is only one layer, that means one summation only. So we cannot fulfill all the case. So let's have a look with the example. So suppose we have collect couple of sample from your classmate. So those are the GPA, so those are the fans, and then those are the mood, happiness or not. So we have collect 1, 2, 3, 4, 5, 6, 7, 8 examples. So the example, if you use a 2D graph to plot it, so the horizontal will be x1, the vertical will be x2, and then the x2 and the x1, the value, for example, x1 is 1 and x2 is 0, so it's set, and then we put the data here. And then again, we have different kinds of data and then put it into this graph. Suppose the data will be put into graph like this one, and then your happiness and unhappiness distribution is shown like this one. So if you only use one layer, one linear equation, summation of one linear equations, so how can you separate all the happiness and unhappiness by using only one line? Is it possible? No, it's not possible. Only one straight line, I'm sorry, only one straight line. So at least in this case, you need one, two straight line, right? So maybe you have a turning point, or you need to have a curve, right? So that is why in mathematical, so in their representation, so if you only using one straight line, it's not possible to separate the happiness and unhappiness. That's why we need multiple linear equations. We need now multiple layer. We need multiple line to separate this data. So just like this graph, right? So it's not possible to use one straight line. At least we need two straight lines. Okay, two straight lines. And then the reason that we are using this one because in our normal situations, so if we use the linear equations to separate all the points, it's not possible to use only one. And that's why we need multiple layer, we need multiple line to separate all the things. Because looking at this, only one simple questions that is only about your happiness, whether your happiness number of friends, and then sorry, it's career here, and also the family issue. You cannot separate all the data perfectly, and that's why we need multiple layer we need so many linear equations to fine-tune the slope, and then finally we can classify, we can separate all the data one by one. So similar example previously. So honestly, it's only a mathematical representation. So the neural network, the mathematical, is summations of all the linear equations. Okay, so you have the linear equation here, you have the linear equation here, you have the linear equation here, and then in each step we are going to use as summations to sum up all the linear equation together. Finally, we have the predicted value. So that is the fundamental mathematics of the linear equations. So a theoretical meanings of all the nodes or layers. So honestly, it's easy to identify the neural network. So you can classify into three different kinds of layer. The first one is called input layer. Input layer. So input layer means all the inputs, right? So all the dimension of the information that you can collect. And then the last one will be the output layer. So what is your expected output? For example, previous case, we have the input layer of the milk bottle image and the handkerchief image, and then we have the output layer of log crying. And then we also have the input layer of GPA and also your number of fans, and the output layer happiness. We also have mentioned in our previous case career and also the education, and then we also output the happiness. So those are the input layer and the output layer. The middle part we call it hidden layer. Hidden layer. That means how you can use the summations of the linear equations to estimate the relationship, to formulate the relationship of all the input and output situation. And those input and output and situations, we are going to find the slope of each of the linear equation, and that is how we are going to do. For the hidden layer, so most likely, yeah, of course, you can use only one hidden layer and then to formulate your neural network. But most likely for the real case example, the hidden layer will be quite a number of hidden layers. So for some easy to understand, and then you are not always asking for accuracy, the hidden layer will be at least 20. And then if for the real case, for example, the CNN, if you want to do some image classification, the hidden layer is more than 50 and more and more and more. Okay, so in the real case Google, so most likely the hidden layer, it can be counted by millions of the hidden layer. So that is the situation. The hidden layer, usually we will try to decrease. So similar to the previous convolution neural network, CNN, convolution neural network that you use to classify the car, you use to classify the cats and dog, etc. You can see the image becomes small, and smaller. The hidden layer become less, and less. And then most likely we have this kind of structure, but honestly, yeah, we can have different kind of neural network, and then you can have different design. If you want to study more, so this is the part of computer science. So how they use the mathematical relationship, and then they use the different layer structure to facilitate or to formulate the real world problem, and then that is the role of the computer science, and that is what we are going to do. You only have to understand input layer, output layer, and then the middle one is called hidden layer. Hidden layer, usually we have loss of the hidden layer, and usually the hidden layer will be less, and less until the output layer. So as we have mentioned in our previous example, the number of bands and then your GPA to predict your happiness, right? So only one hidden layer is not enough, because one hidden layer, so somehow, or I will say that one summations of all the linear equations, it is only a straight line. Okay, it's only a straight line. So if you want to facilitate the real world problem, is a nonlinear relationship. Okay, so most likely you need to have more and more hidden layer, more and more knobs to facilitate your nonlinear relationship. So we have one linear equations, we have another linear equations, and then here is the bias is negative 15, as I remember. So now it's 1.5, it tuned it. Okay, So we have the bypass value, and then this one, the bypass value will sum up all the linear equation. And then finally, the output, the forms will be like this one. It's just like a curve. Okay, it's just like a curve. If it's curved, so somehow you can classify the previous real case example. Previous we have 8 data points, and then data point will be the happiness is in the middle, and then the unhappiness is outside. Okay, so when we have this kind of summation of linear equations, so we can separate. Can you see that? We can separate all the data in a very, very good phase. So all the equations, all the formula that you have learned in the, it should not be high school, right? Linear equation, you learn it in the middle school, right? So Form 1 to Form 3. So in Form 1 to Form 3, all you have learned can be applied into this kind of mathematics. And they are the fundamental things of our artificial neural network, of our AI. Yeah, and then when you are in the real example, you have more and more data points. Even it's only a x1, x2, y. You only have 2 input and then 1 output neural network. So when you have more and more data, so the data distribution will be quite complicated. And then you want to find a good line, yeah, a good line to separate all the data, right? So somehow you need to find, or you need to involve lots of the layer, lots of the hidden node to facilitate this kind of complicated example. But can you see that even this complicated line, some of the data point triangle here, can you see that triangle here? Can you see that it's still outside the boundary, is still outside this area, and then we say that yeah, the accuracy is not 100%. The accuracy maybe here at 109, right? So you have 3. So the percentage here may be 97 or 98%, something like that. So yeah, even a really complicated linear equations like this one, it cannot fulfill the case. And then of course you can add more and more hidden node, and then more and more line to separate all this kind of the data. But the computation power will be exponentially increased. You see that in our previous case, we only have 2 hidden nodes, right? 1 layer, 2 hidden nodes, and then you have 1, 2, 3, 4, 5, 6, 6 node to terms. If you have this kind of shape of linear equations, so definitely you have more than 200 to 300 hidden nodes, right? You have 200, 300 slope, and then you need to tune. It costs a lot of the computation power. And that's why NVIDIA now, GPU now, they are so expensive, because to do this kind of training, you need the computation power, and then you need to spend money. You need to do some calculation to calculate the slope. So yeah, computer science, honestly, they are an engineering problem. Engineering problem we always call is a automation. Automate the solutions by using limit money, by using limit of time. So that is a real world problem. So we care about the money, we care about time, we care about the GPU that we spend on this kind of questions. And that is the situation of the neural network. And here will be a conceptual way to how to do the nonlinear classification. So if you have different layer, and then if you have lots of the nodes, the final output of your classification can be a curve. So if you a curve, you can classify the data in a more and more proper rates according to real world example. So here, can you see that the output is only 2D image? See that, right? So it's only a 2D image. And then because it's a 2D input, we only have 2-dimensional input, and it's 2D. But in real world example, you may find that the problem, they have multiple dimensional, and then in the visualization, it's not easy to do the visualization because they are not 2D. Okay, if it's a 50 input, then it will be a 50-dimensional graph. So 50-dimensional is not easy to output. So in computer science world, so somehow we work more hard than the physical world. But physical world, we only have Excel. Remember, it should be 15 to 16 dimension, right? So we are not living in a three-dimensional world in the physical aspect. So we are living in 15 or 16 dimension. So in computer science, we are more. It can be 50, it can be 500 dimensional, it can be a million dimensional to identify your questions. We have 100 dimensional to input and then output your results. So that is the case. So I also give you one of the example. We will learn chatbot later. And then a few years ago, when we want to buy the computation power, to Department of Computing want to buy the machine GPU to run the ChatGPT 3.5. We spent, as I remember, it should be 34 millions of dollars to do this kind of GPU 3.5 calculation. So that is the money that we need to care and then we need to spend. So that is, yeah, cats again. So who have a cat at home? So for the cats, so we collect lots of the label cat image, and then we put all the label cat image here, and then we let the CNN to classify and then find out the feature of the cat. So they will find out the common feature of the cat. So for example, the eyes, the cat's eyes, and then the cat's ear, the cat's nose, etc. So they have a common pattern. Maybe it's color patterns, maybe it's a line patterns. Okay, so whatever, they have some common patterns, and then we will apply some filter. For example, apply the filter. We're just looking at the shape of their eyes. We don't care about the color of their iris, etc. So we apply some filter to filter out the color, and then we just care about the shape of their eyes. So it will become one of the feature of the cat's eye, one of the feature of cat's ear, and then we combine together. We erase the cat's head again and again. So maybe you will find that hey, it's easy to do it, right? So, but honestly, if you want to have a good AI model to identify cats, right? So you have to your AI model should be suitable for all the angle of the cats. Okay. And why I asked, did you have cats at home? So can you tell me what is the shape of the cat when you take a photo? It's really hard, right? We always say that cats is liquid. Okay, their body is just like a liquid. So when you find a cat at home, so it can be any form of a physical of their physical body. So it can be any shape. Okay, so when you take a photo, so it's hard to identify their patterns, and then your AI model need to fit this kind of situation yeah, it will be your nightmares, right? So they are not quick, and then how you can identify that shape. So it's pretty hard compared with the other. For example, if you want to compare with the horse or if you want to compare with the dog, so they are easier. Cat is quite difficult to identify the shape. So yeah, later on, for example, you have yeah, not later on, maybe we can discuss right now. So previous lessons in your week 2, so you have the post-threat detections. Honestly, for the post-threat detection, so right now we cannot have a good post-threat detection for all the animals. The best one is human. We guys human because it contains lots of the business value. If you can identify the posture of a human, so it returns lots of the money. Another animal that we can identify their shape very well is horse, because all the photos of the horse most likely they are standing or running. So you cannot find a horse that is sitting down or that is lying down on the ground, etc. So if you find a horse that is lying down on the floor, so most likely he or she is close to that. So yeah, that is the situation. And yeah, horse is easier to do the poster detection. So see that if you want to do the cat or dog's poster detection, it will be really hard, especially about cats. Okay. So activation function. So when you pass through a network, pass through a new network summation, so they are not only simply just sum up all the linear equations, so they also have an activation function. So as I have mentioned before, so most likely the easiest to understand is the threshold, right? Threshold, just like the Excel that we have done in our previous example, right? So why you say that is 0.5, 0.6, or 0.7? Why you say that the number of the correct poster key point should be 12? So honestly, this kind of value can be defined by the expert. So just like if you are diabetic, your HbA1c value will be 6.8 or 6.5. It should be 6.8, but we say that 6.5 you will be with start the risk value. Okay, so why is 6.8? So more honestly, this one is designed by the expert, right? But like I have mentioned before, how about the temperature? You say that 23, if it's about 23, and then is hot, if below 23, so it will be cold, right? So 23 is the best warm temperature. So that's why our here all our AC air conditioning in all the AC in our PolyU they set to 23. Why is 23, right? So someone may argue that, hey, 23 I still feel cold. Hey, 23 I still feel hot, right? So we do not have a perfect answer, but this kind of the setting is easy to manipulate because they are rules and then they are threshold, right? So they are defined by the expert. So we cannot argue a lot. Just follow the expert, just follow the number, and then all the calculation will be easier. You see that if it just is a 23 here, or is HbA1c is only 6.8 right here, so all the calculation is easy. Larger than 6.8 is diabetic, more than 6.8 is not diabetic. So that is easy. But for our human being, it's similar to this kind of graph, sigmoid. Just I have mentioned before about the room temperature. Someone say that 23 is not hot, right? But when the temperature increase, right? More and more people will agree that it's hot. So 23 is not hot. How about 30? How about 40? So it's 40 degrees. So definitely all the people will say it's extremely hot, right? So we have a threshold cutoff point, and then if you reach the cutoff point, all the people will agree. So this kind of the mathematical representation, we call it sigmoid. Sigmoid, okay? Some of the this one threshold value will not be so extreme. So will not have so many. I will say that agree, disagree. The degree is so big. So if the degree is not so big, so we use the tangent edge. Tangent edge. So the here can you see that the degree of acceptance or not acceptance will be less. And then another activation function that we always use is the ReLU. So no one agree, no one agree, not agree until a threshold. So this one will be, I would say that they have the linear relationship and increase. So this kind of activation function is designed by the computer scientists. It's designed by the other. So how the mathematical guys is working, they are working on this kind of graphic. They are working on this kind of the setting, and that is the neural network. So all the people knows that computer. I guess all the people knows that, right? So all the fundamental of the computer is 0 and 1, 0 and 1. So all we process the data is go to the binary level and then 0, 1 and 0, 1. Yeah, don't talk about the quantum computing first. We only talk about the computer system that we can touch in our normal life. So all the things are binary number. For example, in our previous example, we want to identify the digits, whether it's handwriting 1, handwriting 2, 3, 4, 5, etc. Right? So how I can identify the digit? So we have the here we have the square root, and then if someone have the writing here, and then we put it 1. If without any writing, that means empty space, we put 0. 1 0, and then we have the input layer that is 0 0 0 0 1 1 0 0 0 etc etc. And those are the dimension to identify an image of the handwriting. 0 and using 0 and 1 to identify whether the digit they are the digit 1 2 3 4 5 etc etc. And then throughout the neural network, so we try to understand with the relationship of this kind of input layer, and then finally we have the output layer. Hey, from 0 to 9. So this one is the digit 1, and then we estimate this situation. So you can find that if it's not a numeric problem. So happiness of is based on your number of fans is numeric number, and then it's based on your GPA is also numeric, right? If they are not numeric problem, they are some real world problem. For example, identify the handwriting of your digit 1, 2, 3, 4. Such kind of easy problem. So you have loss of the input layer, and then you need to formulate this kind of problem into some method that can be understood by the human. That can be understood by the computer, and this kind of process is really painful. You see that yeah, only a small digit, so we have so many input layer, and all these input layer is 0 and 1, 0 and 1. They are all digit. So golden rules of the neural network to identify the neural problem, you have to find a way how we can change the input data, whatever is image, whatever is voice. So we have the voice. You have to train it into primary data, and then it can be encoded and processed by the computer. So you can see that in the real example for the digit, right? So the digit 5, and then when we write down 5 here, so the input layer will be here, example, 28 times 28. So that's why I say that, hey, in the computer world, we are more complicated than the physical world. Physical world is only 15 dimension, right? But you see that just a simple handwriting, we have 28 times 28 dimension is the input. So totally almost 800 dimension. And then we have 800 dimension of input. All of them are 0 and 1, 0 and 1. Maybe you can also use the color we will discuss later. And then we pass through hidden layer. And then hidden layer, we have the 128 hidden layer. Finally, we have the output. And then identify whether it's 0 to 9. Okay, this one it should be 5, right? So this kind of easy case example. So we need so complicated situation to handle. So that is, yeah, AI. That is the word that behind the AI. So how about the image, right? So image is more complicated. So you have the color code. So all the image right now in your computer, in your smartphone, so you can divide by a small rectangle. So all these kind of small rectangle combine together to become an image. All the image combine together to become a videos. And then for image, you have resolutions. For example, webcam right now I'm using to record me. So the resolution of a webcam, it should be 320 times 240. So you have a HD, you have a 4K, you have 8K, etc., etc. So those are the resolution. That means number of pixel, number of small rectangle within one image. Okay. So if you want to process a webcam data, so the number of small rectangle will be 320 times 240. So this kind of data. These are our input. And then in each rectangle, we have a color code. Okay, we have a color code to represent the data. So right now, the color code will be numeric data. Numeric data. So yeah, the color code can be defined into two different color code in computer world. So one is called RGB, another is called CMYK. RGB is for something that can generate the lighting. Okay, so here your LED screen, your LCD screen, your projector, etc., your monitor, they are using the RGB. RGB. Okay, they generate the lighting. So when can we use the CYMK? CYMK is using for those who cannot generate the lighting. The color code who cannot generate the lighting. So yeah, what is the object that cannot generate lighting? For example, your printout, the poster, the paper, they cannot generate the lighting. So the printer, they are using the CMYK color code. But for all the lighting device, they are using RGB. RGB is easy. So RGB, they are using the red, green, blue color to represent all the things. the red color starting from 0 to 255, green color again 0 to 255, blue color 255. So if you change into a 16-bit, it should be 0 to FF, 0 to FF, 0 to FF. So those are the color code of a computer system. So let me ask you some simple things, right? So if the color code is 0, 0, 0, 0, 0, 0, okay? So all red, green, blue are 0. So it's a black color, or white color. You turn off the green light, you turn off the red light, you turn off the blue light, you turn off all the light. So the value is 0, So if you turn off all the lighting, then the color should be black color. So yeah, if you turn off all the color, it will be black color. So if you turn on, yeah, here, see that? 0, 0, 0, 0, 0, 0, it is black color. So if you turn on all the color into the maximum intensity, so 225 in red, 225 in blue, 225, 55, so sorry, 255 in green. So you turn on all the lighting, then it will be white color. It will be white color, okay? So you have the black color, you have the white color, and then if you only turn on the red lighting, so it's FF 0, 0, 0, 0. Turn off the green, turn off the blue, turn on the red into maximum color, so this one will be red color. So you have the similar logic, and then you can turn all the image into a color system, and that this color system, they are numeric data. This numeric data can be put back into computer to process, and that is how our AI model is doing. And yeah, that is the situation. So if you want to process an image, so for example, in our previous example, you use the VIT pulse to process the posture estimation, right? So yeah, mostly for a webcam, the frame should be 25 frames per second. And then for your monitor, some of you guys will choose higher, 50 to 100, and then that means you have 50 image within 1 second. You have 100 emails within 1 second. And that is how our computer system is processing their data.